Hello again, one more little video for you. Once again, we're Satisfactory, factory building game. We've showed off basic manufacturing and trains. And you can see my little truck here, and truck station. Works a lot like the trains. It can load and unload freight and go across country, and it doesn't need tracks, unlike the train, which is less upfront work to set up a route. I thought I'd take one more video to show one of the more better laid out operations in my factory. It's reasonably sophisticated, requiring a number of different inputs, and it produces iron beams. Steel encased iron beams, actually, which are important for building more advanced structures and things. So, you can see that we have quite a lot going on here. I'm going to lay it out to you. I'm going to explain a little bit. I'm not going to go to each of the resource mining machines that feed this operation because they are several. But you can see here we've got some limestone coming in, and it's coming in with other limestone lines. Those limestones are going to be ground up in this top level here and turned into concrete. So we have a tremendous amount of this limestone coming in. We've got about these three conveyor belts that you can see coming up this ramp and feeding this operation. We've got about 510 of these limestone units coming in every minute, if I recall correctly. And we need to split that up evenly between these 12 machines that you can see closer to the front edge of this operation. That number is intentional. It's basically precisely the number we need to feed those 5 assemblers down there the concrete that they're going to need to make those beams. There's a lot of math in this game. And we don't have computers that just say, okay, send 10 this way and send 12 that way. We have to physically manipulate these feeds to split the stones up so that every machine gets exactly how much they need and no more or no less. Each of these machines need 45 limestone per minute, which, if we multiply that by 12, that's 450 plus 90, 540. So I don't have 510 coming in on those conveyor belts, it's 540. And we have all of these splitters splitting things up so that we can turn these 3 streams of, I think, the bottom one's 120, the middle one's 180, and the top one's 240, as I recall, per minute that are coming in. So we have these arrays of splitters set up to split the feed first from 120 on this line to 2 lines of 160, and then those 2 lines of 160 twice again into 4 lines of 30, and it's already getting hard to follow. This took hours to lay out, doing all the math and then actually physically finding a way to route all these conveyor belts that would actually work together. So there's all this splitting going on. Part of what makes it complicated is you can't just split 120 into 45. You have to split it down into smaller numbers. I'm actually splitting it down into 15s and then using these conveyor belt mergers to put 3 lines of 15 together into 1 line of 45 that feed into one machine. And then that's done across what was it? These 4 machines here, yeah. So that was complicated. Then next we have a line of 180 that has to get split up between 4 machines. Or no, I think that first one's just 3 machines, and then this next one is 4, I think. Been a while, don't remember exactly what the math was, but this one's even more complicated. Instead of splitting it into 2 and then splitting it into 2 more and then into 2 more, this one splits into 3, and then each of those 3 splits into 2. So you can see there's the coming in. We have, this is the 180 line. Comes in and then it splits into 3 different lines. And then you can see those there. And then each of those lines gets split into 2. You can see one coming out here, one coming out there, and they go out to different machines. And then those machines split into 2. And then eventually we have lines of 45 coming into the machines again. This last line is 240, so it's even more complicated. Now, I was trying to conserve a lot of space over there because I wasn't sure how much space this 240 line was going to take. Turns out not quite as much as I anticipated. Things are still pretty crammed in here, but I ended up with this open space here that I didn't have to use, so I could have done it a little neater if I'd known. But anyway, that 240 line comes in and it splits 2 ways. And then each of those ways splits 2 ways. And then each of those ways splits 2 ways. Pretty soon we've broken that 120 and down into lines of 15. And we can put together 3 lines of 15 to feed 1 machine. Then the output of these machines is being manipulated so that once it goes down, instead of having 12 lines going down, we have ultimately 5 lines. Now it's 10 lines up here on this ledge, combined down into 2 lines down there, that split that, how much was it? Each of these machines is producing 15 concrete per minute. So there's 12 of them. That's 180 concrete per minute. And we're splitting that 5 ways. Once again, we have to do that crazy splitter math, because we can't just say, send 36 concrete to each machine. We can't do that. In fact, there's no way to split 180 into 36. It doesn't work that neatly. What we end up doing is splitting this stuff. Having 10 machines going down, and then for each 5 machines there's 1 machine that isn't sending concrete down to the floor. It's instead sending concrete over to the other lines, so that the 15 coming out of this machine gets combined with roughly 3 from this last machine. So we have 2 lines of 18 coming down to finally be combined into 36 per minute. Extremely complicated. And it's not quite as neat as I'd like, honestly, because it isn't being split evenly. It isn't coming straight out of the machine supplying. It has to go back around and kind of wait for its turn to get into the line. And as long as these lines stay very full of concrete, it works out. But if they were all empty simultaneously for some reason, we might not have precisely 36 concrete going to each of these machines. But overall, it ends up working out. This is probably a little more precise than it strictly needs to be, but I wanted to make sure I was making the best use of the resources possible, because it requires a lot of resources. Limestone isn't super hard to come by, but some of the other things being fed into this operation are. Coal, you can see there, is a little bit harder to find than limestone. It's It's a little bit harder to find than the iron ore, which are the other components ultimately of concrete encased steel I-beams. We need the coal to smelt the iron into steel. Steel requires iron and carbon to be made in real life. And so in this game you need coal fed into a special smelter that is able to produce steel ingots. It needs iron and coal to produce steel ingots. And we have to do that splitter math again, getting our lines of coal and iron to be split up into 45s again in this case. And in order to supply those 5 assemblers that make the I-beams, we need 8 of these smelters. So we have 12 concrete, limestone grinders making concrete, and then we have 8 smelters producing steel ingots. And then we have to do that same song and dance we did with the concrete upstairs, where we have every 3 machines that are producing steel ingots have a 4th machine that's producing steel ingots that doesn't feed straight into the assemblers making the concrete encased I-beams. It instead feeds back around after splitting several times, splitting things down into 3s again, where it can send those I-beams over, get split up and sent into each of the individual lines. You can see those mergers there. Be added to the 15 that each machine is producing, so that each of these lines is sending out 18 steel beams per minute. And then those 18 steel beams and those 36 concrete get combined in the assembler to make 6 encased industrial beams, or concrete, steel reinforced concrete is what we call that in the real world. And then we feed it out. Each of these machines comes out and goes into a merger, and then into another merger again, before finally arriving at what would be the local storage, but we're using this stuff as fast as we can make it, so this storage container is currently empty. And then this conveyor belt goes all the way back to our main operation, where some of it gets sent off to storage that I can access to pull those encased beams into my inventory for when I need to run off and build something. And some of them are instead sent off to other manufacturing machines that will turn them into even more sophisticated products. Because, well, steel reinforced concrete is a building block. It's not really a means to its own end. It's a means to another end. So, you can see the conveyor belt's quite long. And we're in the spaghetti bowl now, where there are dozens and dozens of conveyor belts. So this line goes to storage here, as you can see. And there's a splitter right back over there that sends some of it off to this sink. This machine over here consumes some of those beams to produce something else that we need. I'm not going to get into it right now. But we can also send them off to other machines as necessary. We'll just slap another splitter on this line. Anyway, that's the steel reinforced concrete operation. It's not quite the most sophisticated thing I'm building right now, but it's one of the things that looks the neatest, and I thought I'd share it. since a lot of thought went into trying to make that operation as efficient as possible. Thanks again for watching. I hope you enjoyed it, and we'll see you again later. Bye now.